So after my last couple of videos, it seemed like I was getting very near the end game of Satisfactory. So I looked at the things I need to build for the final push to feed the elevator, and not worried about the quantities there, but the items that have to be built for the last delivery up the beanstalk are complicated. And to build them in any sort of volume, I'm going to need to build out a really large number of things. So I sat back and thought, well, let's do this one step at a time. And I started planning out the factory. And it turned into a big yak shaving thing where, oh, I need this, but before I can build it, I need those things. What I came down to was that the nuclear power that I had just built, which is about 90 gigawatts, probably isn't going to be enough. Let that sink in. 90 gigawatts is probably not going to be enough. And my existing battery production, once I get everything cranked up with all the drones flying back and forth delivering things, existing battery production is not going to be enough. So started planning out what I'm going to do. Now, all along here, I've been writing up some Python scripts to work out how to build things and the right ratios. And if I want to build so much of this, I need so much of that, and so on. Kind of an extension of the planners we have on the web. But since all the coding is under my control, I can ask it questions that I can't ask the ones on the web. Mostly things like, what if I want to use these two different recipes? I want to use the main recipe for something, and I want to do some with the alt recipe. Now, I can do that here, but the planners that are out there on the web don't generally allow you to do that. I could also flip things around. I could say I have this much of a resource, and how much of that can I build from it? And it gets pretty complicated. But in the process, I've built up my local knowledge, my local data storage under Python. And I have, I think, 225 recipes now all set up and placed into some JSON files, and I can peel it out and analyze it. And I thought, well, let's walk forward through all the recipes, starting with the ones that have no ingredients, like mine copper. And at every level, I'm going to look at the item that's being built and all the recipes to build it. And I'm going to pick the main recipe that I want to mostly use for that. And using that, I'll walk forward through all the recipes and kind of put them in layers. So we've got the first layer, which is just things gathering. And the second layer is, what can I build with those gathered things? The third layer is, what can I build using second layer? And so on, all the way down to the end. And at the far bottom end, we've got a few very high-level things that require like 8 or 9 layers. That's fine. Then I could go back and I could say, like what we've got on here, let's work out which of those recipes I need from which layers and organize how to build what I want to build. And the first thing I wanted to build was batteries. I need a lot of batteries. Well, batteries need sulfuric acid. And I'm going to need some aluminum casings. So I've got all-clad casing, which requires copper ingots. And my aluminum area, I've already reorganized this a little bit. So let's read it forward. We start off by pumping some water and getting coal, quartz, copper, bauxite, and silver. You got all these things rushing in at layer 1. And then the next layer, we make some silica and solution and scrap and ingots. So there's our, we've seen this particular combination before. That's our aluminum factory. It's got a little bit of a water loop in it. And then we grab some copper, make some ingots, and use the ingots to make aluminum casing. So the all-clad casing, I've forgotten why I picked it up. I think I get a better yield of all-clad of casings per ingot if I use that recipe. One reason I do this is because I can't remember all of the details of all the decisions I make for all the intermediate products. And for the batteries, it wasn't too bad. And at the end, you get your sulfuric acid and you get your batteries out. And I started combining everything, and that turns into this rather more explicit table, which I produced. The first one we were looking at, this one was produced semi-automatically, and it doesn't really have enough information to build a factory from. I have no quantities here. But I can toss that into a bit of Python code, which if you're quick, you can read. And it will look through that initial plan and it will say, okay, well, to do that, I need to set up a table that looks like this. And I already have code that will take this kind of table. This is a specification for what I want the factory to do. And at each layer it says, build this recipe with these parameters, things like how much do I want to overclock it? And then I can say things like, it's a Mark III miner, it's on a normal node. I can say, I want to fill an order for 300 batteries. Or I get down here, I can say, I want to fill the pending orders for silica. And as I see each one of these, I'll say, okay, well, I'm going to make a note that I need to build a factory to make this recipe. And fill is going to tell me, how much of it I need. It says pending copper ingots. So look at so far how many copper ingots do I need and what do I need, and it will mark that as filled and it will put in a request for the next thing down. And this particular plan, I'm using fill all the way down. This is the simple one that says I need batteries. I'm going to use this recipe. Print me something that tells me, to do this and do it all in order. So it gives me a better human scale thing. This is the initial version turned out by this little scripting. And this needs tuning. This is not properly ordered. Its tuning is wrong. It doesn't really, it says OC250. I'm going to be clocking things differently. But this is the output. I pick this up and I edit it, make a copy of it. And what I came out with is this plan. Say, well, let's start off by saying I'm building 360 batteries. I actually increased it from the 300 because 360 gave me better numbers. We'll see how that feedback loop works. And locally, all in one building, I want to do all of this stuff kind of on one foundation. So I want to make batteries, and I need to make the all-clad casings that build those batteries. I need to make the ingots that build that, and the scrap, and the alumina solution, and some water. I want to put all that stuff kind of in one place. The reason why I want to keep that co-located is there's a water loop involved there. And you don't want to be shipping your water on a train or on drones or anything. You just want it local. Then somewhere else we can go we can pump some water, make some sulfuric acid, but sulfuric acid is also liquid. So really this is all part of the same building, same close, keep me close in. Somewhere we need to make some copper ingots. And for the moment, I am preferring to use take the ore and a bunch of water and toss it into a refiner and get a little better yield. I can relax that as I finish up my planning, but that's what I wanted to start off with. Then we also needed some silica and some mining of stuff. And I thought, okay, there we go. And that's where I specify the goals. And now I use this, I create a planner object and run the plan method on this, and it will step through this process of saying, figure out what I want and what I have, and then figure out what I need to build and what I need after that. And it comes out with this nice stuff here. So I say, make 8 blenders at 225%, building this recipe. And here's a reminder of the inputs and outputs. So as I'm looking at this, I know how to route belts and pipes. And then make 4 of these, make 4 of those. I started looking at this recipe, this thing, this whole plan here, and I scratched my head and I thought, some of these quantities are going to be too big to run through a single drone port. And in fact, it divides very neatly into 8. So all of these guys are only 4. I could run this at half the overclock. So I jumped down and I said, well, let's reduce the quantity and make it by 8. And then I broke it out into separate little bits. Then we started implementing. So what I'm calling outpost DD underscore 1A. DD1, this is for Dune Desert Project 1. A is deployment A, factory A, building A, whatever. So building A, I'm going to mine raw quartz and turn it into silica because nobody else needs raw quartz. I only need raw quartz for the silica. So let's start off with that. I'm going to say, yeah, 100 raw silica and give me the plan for that. So I do this really simple thing. And this gives me just the bare minimums for making silica out of raw quartz. And normally I would do silica on site. I'd bring in the raw quartz and I'd make the silica here. But then I thought, if I have to have a whole ton of silica, and I'll need a ton of silica later on for other things, why not, have a whole bunch of little outposts. Each one has miners on, one or two or three silica nodes, depending on what's available right there. Turn it all into what I need, which is going to be raw quartz, or silica, or maybe quartz crystal, and then I just ship it out from there. And yes, this does mean that I'm shipping 10 silica for every 6 raw quartz. I think silica stacks to 100 and quartz stacks to 50. If that's true, then this is actually more efficient. Anyway, doesn't matter whether it is or not. There's not a whole lot of it. So I went and built this up, and I've got an outpost out there on a silica node that is getting me, on a quartz node that's getting me silica. And then I did the same thing with copper. Whoops. There we go. Fix that back up. Next thing was I need copper ingots. And as I was messing around with this, I thought, I could mine some copper and ship it over to somewhere I've got water and refine it and turn it into pure copper ingots. Or, because I only need 240 a minute, I just said, well, let's drop in some smelters. So we have got a copper mine somewhere with a miner, and we're turning it into copper ingots right on site with the simplest possible starter recipe. That's fine. Same thing with coal. Coal, we just mine it. Oops, and again, last time I edited this document, I didn't rerun everything properly, so we're going to be fixing things. So coal is just mine the coal and toss it into a drone port. Oh, I know, it was a global change that I did when I was setting up these, specify the goals and construct the plan. These are headers that I didn't used to have in the document. Okay, sulfur, again, we mine, and I'm giving an alternative. I'm saying either make 2 miners at 187.5% or one at 250 and one at 125. So I'm giving alternatives here as part of my computations to work this out. Often during the planning process, I will see this and I'll say, well, I am going to use this one. So let's request an overclock of, say, 190%, and it'll put 187. That's close enough. And this says that I will be shipping 900 sulfur around. So I've got 2 Mark III miners on sulfur, and we're shipping 900 sulfur around, which means we actually have a couple of different places this is happening, and there's many drone ports shipping sulfur. We'll see what happens with that shortly. Bauxite, again, we have a missing table marker. There we go. So bauxite, we again need 2 fully overclocked Mark III miners because we're going to be eating 1,200 bauxite per minute. Now, what I ended up doing was, for these big guys, the sulfur and the bauxite, I actually ended up with 8 drone port pairs. You'll see why in a moment. So last one is outpost DD underscore 1Z, and I'm going to use Z for the final one, so I can always find the Z one. I can say DD1Z and have it show me the final one. I don't need to remember it's like DD1F is final for DD1, but DD2 has DD2H. It'll be Z. So DD1Z is our final assembly for batteries. And I had some alternatives here. And this is where I decided that things were going to get a little weird because we need 360 batteries a minute. I saw everything looked really nice for dividing it into 8. So instead of 8 blenders, I wanted one blender and want to replicate it 8 times. So I want to do a build with one blender, one battery blender, and then lay that out and then duplicate that whole thing 8 times. And this is doable mostly because we have blueprints. So now, making this decision to plan out a build for 45 batteries, I am thinking in terms of packaging this whole thing, this whole line, in a blueprint or 2. Turns out I couldn't fit it in one by any means. I started laying out, I was like, oh, that's not going to fit in one. It actually ends up in 2 full-size blueprints plus an extra blueprint to do some piping for buffering. So that's where things went 8. So where we've got a lot of sulfur or bauxite coming in, what I end up with 8 drone port pairs. So I get the sulfur coming in. There's a drone port out there that's being fed sulfur, and there's a drone port here that's receiving it, and I just pair those up, and they send the sulfur back and forth. You can have one local guy, multiple local guys fetching from the same remote, but when I started doing that, things got weird. Okay, so here is the plan that I ended up with. So we want to make 45 batteries on there, and then casing and so on. This is our normal set. Let's go down and take a look at execute the plan. Hold on, let me clear this out and make sure I'm getting a clean execute on it. So, all of that comes down to, after we've tossed out, do this at a remote outpost, do that at a remote outpost, we end up with a build that fits on the screen here. And we see it's a blender, an assembler, a foundry, 3 refineries, and a water source. That is doable. And the net imports per minute for this, just for one strip, these are all doable numbers. We can count on drones to deliver anywhere from 250 to 400 per minute, depending on how far they're flying. 150 per minute per drone pair for bauxite is easily doable. I would do twice that and keep an eye on it. And down at the bottom, I peeled out of the side of it without going through the Python our net. So for each item, how much we added to our inventory and then how much we took out. So we're noticing at the end that our strip gets 45 batteries out. And here's our net input quantities. That all matches. So did all that planning. I thought, oh, this is going to take all day to build. Well, it turned out with it broken down into bite-sized pieces like this, I basically went out and said, oh, I need some silica. Boom, done. I need some copper. Boom, done. And 1A through 1E went really fast. The hardest part was just finding the nodes and getting to where they are. And then I did the building, and then I had to route power out to them. So mostly it was the time spent was flying around, but because I knew where I was going and what I was doing, I didn't have to faff around with a much larger build. And I got down to the battery assembly, and like I said, I ended up with 3 blueprints. So let's get rid of Emacs.
I'll tell you when
and you'll notice that this is my battery factory, and it's laid out in strips. So off to the right are the drone ports for the lower quantity things. For instance, the actual amount of copper ingots and coal, they're not large. And what I can see here is that, oh, right, I've got, I didn't take away my sinks after I was done testing. So basically we are accepting silica as fast as it will come from the road. And it's going out on this belt, and it's going zoop all the way down to the other end. And Any of the silica that isn't picked up and used is being turned around and zoop, coming back out here and getting drained. And the total amount of silica we need is fairly low. So I put a sink here so I could monitor how much silica was coming out the other end. And I did some quick comparisons and counting, and at the time it looked like it was about right. And I will agree now it's still right, because the latest check I did, everything is running at rate. So we've got the shared stuff that zoops across the top of the whole thing. So we've got a belt that goes like copper down there in the middle. It goes all the way down, and everybody's splitting off of it. And the battery line comes all the way back. The battery line actually snakes through all of my drone ports. First, it fills up the drone port for outgoing batteries, which is over here. So I have a port called DD1Z has batteries. So if anybody else needs batteries, they can say, set up a drone port, and they could say, go fly to DD1Z has batteries, and then come back to whoever you are, like a DD2X wants batteries. And it'll pick up batteries and move them. From there, that same line feeds all of the other drone ports. So there's our shared stuff. Now, the strip, we've got our two high quantity inputs here. There are 8 sets of these. So that means that instead of having one massive input of high quantities of bauxite and sulfur, which I then have to split out, I just set up a drone port for each one. And these drone ports don't have to move much. I don't trust this number. We're not using 254 sulfur per minute, are we? Well, let's take a look here. Where did Emacs go? So for sulfur, we're actually using 112.5 sulfur per minute. So I don't know what the incoming transfer rate is on this, but maybe it's the maximum transfer rate you could get based on the stack size of sulfur and how far it's going. It's per minute, and the round trip is 2.81 batteries per minute, 3 minutes 32. So it's probably the round trip time, well, the number of stacks that we can move, the round trip time combined with that, and the size of the stacks, and you get this, here's my capacity. So I will assume from now on that once things are stable, that's going to be my capacity per minute. We've got sulfur, and we've got bauxite. So those come in, and we've got our normal back-to-back aluminum machines here in white. So we've got the one that takes the bauxite in the water and turns out the solution in silica. And we've got the one that takes in the alumina solution and coal and turns out scrap and water. And the water then gets cycled back. Here's our water supply for the strip. And unfortunately, it's kind of dark down here, and I haven't set up any lamps. What we see here is that our freshly pumped water comes in here and gets dumped into the top. And because of the way fluid dynamics works in Satisfactory, the water coming along the bottom has priority. So when these guys want to decide how to fill up this pipe, it will first take it from this pump. So this pump is pumping in recycled water, and I've got my little sign here. It says water in 225 per minute. That's for that guy. And water in 112.5, that's for that guy. So we've got these two, which are mainly being fed from a combination of, well, they're being fed from the combination of the recycled water. Did I label this one? I did not label this one. This guy's sending out 67.5 water per minute, plus the 30 is like 90. So we've got some water coming in from the right, and we've got a water pump coming in from the left, which is topping it all up, and it gets used. So that's our normal water loop, which we've seen before. This particular combination is not the one we saw in my aluminum factory because we have sulfur. Batteries require a lot of sulfuric acid, so that's where this comes in, and it kind of changes the mix on how things come together, but the geometry is still the same. It just means that we're using a lot more water than just the aluminum would use. And that whole square, that whole 4x4 area inside this cutout, inside this first cutout from the top, it's 4x4. This is a blueprint. Second blueprint is this guy over here, which actually has the blender, which is being used for batteries. And it has a couple other things. So the blender is in a blueprint along with the assembler that makes the casings that we're going to need for the battery, along with the aluminum ingots. Now, mostly aluminum factories are going to turn out ingots and turn them into casings. So I could have built an aluminum factory separately and then imported the casings. And I thought, well, no, because if I do that, the critical supply of aluminum casings for my batteries might get chewed up by somebody else. So he's got his own on-site. That's for that same reason, all of these drone ports are dragging from material sources that are marked DD1, so they will only be used for DD1. The purpose there is that nobody else is going to use the resources that DD1 needs in order to make batteries. So the only thing we are dependent upon that is not marked DD1 is electrical power. And this guy, I believe I put in a power switch. I've got to cut power to it briefly. Bump. Okay, so our maximum consumption from that particular factory is 5.6 gigawatts. So almost 6 gigawatts just to make batteries. Turn that back on. So that's the second blueprint there. Just assembler and a foundry and the blender, and that blueprint kind of has everything hanging off the left. So we've got the interconnect belts and the interconnect pipes that come up to this line and stop. And this guy has the same interconnects that come up to this line and stop. And in the middle here, I decided I was going to buffer all of the fluids that went between the two, because when you are producing a fluid, it's not a steady dribble, it's a burst. So you produce a whole bunch of stuff and it goes into your local, it goes into your refinery and fills up this thing here, and then it bubbles out, and that's kind of bursty. It could stabilize, it could smooth itself out, but in practice we've got a lot of bursty stuff. So I'm going to put fluid buffers on the output, and we'll see that we have a little bit of water in this one, and I've got some alumina. This is actually filling up. Alumina may have a lot of head lift on it, and then sulfur just a little bit. So the alumina, we've got a big chunk of alumina sitting there. Might also be that the alumina got started and started pumping alumina in the fluid buffer before the person using the alumina was ready to receive it. And that's here. Well, that makes sense because this isn't going to actually start using its alumina until it's got the casings and the acid. So there could have been a delay there, and it probably filled up the buffer. And this is the third one. I didn't want to be running the pipes and getting the buffers slightly elevated so they could tap in properly like this. Oh, and this also means that as we produce more sulfur, it will preferentially drain the horizontal line before draining out of the buffer. So the buffers will come into play when we don't have another source, which is what we want. We get down to the end, and I can check health by just opening up the blender and saying, how am I doing? This is running at 96%, and that was solid 100% earlier. The time that I had the factory turned off while I was checking the power bumped us down by 4%. So these guys should all be, in the high 90s, mid 90s, high 90s, 96%. probably should have gone over this before I checked the power. So anyway, that gives us all of our batteries up, but I didn't go over all of the detailed routing of all of the belts and such. Anybody who is at this stage of play where you're scaling up your battery factory so that you can run thousands of drones blanketing the sky, if you're at this stage, you should be able to put this stuff together, while watching a YouTube video. This is just bread and butter. Okay, I need here's the items I need. Let's put them in place. Okay, now let's belt them up. Oh, I need to move this over here so the belts are shorter. I need to move that over there so the pipelines are right. So I'm assuming y'all can do that. Maybe, I don't know. Maybe someday I'll do a tear down of one of these and we can go over it all in detail. But the battery factory is not the most interesting thing. I think the most interesting thing is the methodology that I used to do the planning, which broke down the problem into pieces that were small enough that I could actually use them. So that's DD1. What about DD2? DD2 is bigger. It's a lot bigger. DD2 is the nuclear complex. I need to build a nuclear power plant which eats an entire normal uranium node. There's 4 uranium nodes in the game. There's one impure, which I'm using for my other reactor. That gets me 90 gigawatts. There are 3 more which are all normal. And the one I want to use is a normal node. And I am still planning this, but it's got the same idea here. This is actually almost the same thing I used above. I believe I augmented this a little bit so that some of my planning could be out of order. But here's the plan. It turns out I want 30 nuclear reactors. And now we see the other syntax, which says I want to do non-fissile uranium, which is part of my nuclear waste stream. This is all reversed from the original order, which is why the headings are below the blocks. And when I want to do how much non-fissile uranium it is, it's use up all of the uranium waste turned up by the reactors, and then plutonium pellets, we use all the non-fissile uranium and so on. This is actually incorrect. Okay, this is another place where you have to adjust. You have to look at the plan that this turns out. This is real simple code, which is just reversing the order of the plan and formatting it into the table form that other code can use. So we have to take this and edit it further. And so far, what I've done is I have investigated some things. I've made some decisions which I've memorialized. I'm still thinking about whether I want to use Rail or not for some of my bulk resources. I may not. I may simply, fill the sky with drones. And here's the plan that I ended up with. I have adjusted all the overclocks so that all of them are balancing out. I have adjusted here. So for instance, the non-fissile uranium, I only want to use 3/4 of the waste here so that the other quarter can be used. I think it's in the plutonium pellets where the accelerators take uranium waste and they also take non-fissile uranium. So this becomes the main plan, and inside this plan I started organizing them. What do I want to do for my outposts? So I've got the nuclear power plant, which is this much of it. My idea here was that I would have the main area, which would be the power plants, all of the radioactive stuff except for the drones moving uranium ore, and it would have all of the things bound to that by fluid loops. So for instance, we're making our nitric acid and sulfuric acid on site, so we're not packaging it up. Nitrogen gas is available in certain places, but those aren't the places where I want to put this. So I will be unpackaging nitrogen gas and bringing it in. Alternately, I could have probably made the nitric acid on site where the nitric acid was or the nitrogen is being pulled, but I ended up not going that way. So I'm going to have my main power plant. I will have a outpost that I'm calling the bauxite outpost, which is going to turn out basically all the aluminum stuff. So heat sinks, casings, ingots, scrap, the aluminum solution. I think the only thing I use from here are the heat sinks, but I'm not sure. I'll have to look down at the plan. I need a petroleum area. We need rubber. I couldn't. I thought there was a way to get away without doing any rubber, and I looked at it, and it turned out that I needed more of something that I had. I think it ran me out of Caterium or something. So I do have an area that builds some rubber. It's not a lot. Modest amount of rubber, and as part of this, I need to do something with heavy oil residue. So I just turned that into fuel and burned it. I have a quartz outpost, which is responsible for doing quartz crystal oscillators and beacons. A Caterium outpost, which is not just going to do Caterium ingots, but it's going to do the quick wire and the AI limiters and the control rods, all there at that one outpost. So bigger Caterium outpost than I've done. Usually Caterium, I will just take the ore and turn it into ingots and ship it out. But this time I decided to go ahead and put the quick wire and all that. So these guys are going to be there at the Caterium, wherever it is I place that down. I'm assuming I've got a Caterium source that can handle that entire outpost. If not, I will have one of them do it all, and the other ones will ship the ingots. I'll probably split it by ingots. Iron and steel, I started trying to group these separately, and it came down to, well, I really want to do reinforced iron plate with the bolted iron plate, and I want to use steel screws and steel beams and steel pipes, and I end up with iron wire and cable and stator, so all of this stuff. I could have done copper wire and cable, but then I'd be moving the cable in from elsewhere, and I wasn't really sure about relative availability of iron and copper. We still may move that around. This is not finalized yet. And down at the bottom, I still have placeholders for here are the things I need to mine. So I am assuming, okay, so for iron and steel, I'm assuming I'm going to have to import ingots. I guess I had already made that decision, or maybe I just haven't moved it up yet. Now, after doing this, this actually places its output in a separate file. It's all nicely organized here, so I can go down here and say, well, what are my plans for the Caterium outpost? Well, it's simple. I've got 7 assemblers and 6 assemblers and 15 assemblers and 9 refineries, and oh boy, and water. Okay, so the reason why this was separated from the Caterium mines is because I decided to use the refineries because we need a whole ton of Caterium ingots. This is absolutely calling out for me to see if there's any other way I have of making Caterium ingots that might use less Caterium ore. Still, this is 2 ore per ingot rather than the 3 ore per ingot from the main recipe, so maybe. This still means that for inputs, we're going to require a ton of copper. That's where I stretched it. So I was using the fused quick wire, which brings in copper ingots to make the quick wire. Because look how much quick wire, 1,800 quick wire per minute coming out of this guy. And this is just for our nuclear power. I'm hoping that this isn't going to carry over into the other things. So this means the Caterium outpost is making these things. It's a very large outpost. Does need to be by water because we've got 9 refineries sitting on water. That's going to be a neat sized thing. Glad I opened that one up. Like I said, I still am refining these things. Iron and steel, we also have a whole bunch of things to build here.
Yeah, it's a quest.
These are going to be fairly large buildings. Again, this is all just for power. Because we will not be starting off with a factory. When I did the nuclear reactor on the other side, I had local production for all of this stuff that was already there, and now I'm building a new area. I'm not going to ship this stuff across. Copper. Yeah, copper ingot. We need a lot of copper ingots. We need 1,750 copper ingots, most of them for the Caterium. We'll probably build the copper outpost on the water somewhere near the quick wire outpost. I may even build from one to the other. This is the sort of thing you learn as you start to organize it. And we still have a bunch of catch as catch can, remote mining, but these are all onesie twosies. So in these cases, while some of the quantities are fairly high, the biggest is 1,000 copper ore per minute. That's still doable with pairs of drone ports. If I wanted to lay out a train, I'd have to have the train visiting all of those nodes and delivering it to all of the proper destinations. I'm liking the drones a lot more. Anyway, so that's what I've got planned, and I'm going to start work on this. I've already broken out. I'm going to start breaking things off of the bottom of the plan here. I've already broken out the nitrogen supply, so it didn't even appear in the instructions anymore. That's real simple. So we're going to grab some nitrogen from the ground wells and package it up. And this is going to form an empty fluid tank loop with its consumer. So we will just start off with a bunch of empty fluid tanks. You may have noticed this earlier. Hold on. Got a cat who wants some attention. So you may have noticed this earlier, but I already have in my inventory enough empty fluid tanks for 3 nitrogen loops. The idea is you have a bunch of fluid tanks, you start filling up at one end, and then you fly them over to the other end as they fill, and then you fly the empties back as they drain. There's a cat for you. Screamed to be picked up, and then struggled and took my headphones off as she jumped down. So you don't want so many empty fluid tanks that your drone has to stop and it deadlocks the system. It's okay that you have enough tanks for it to stop somewhere, as long as that only happens when the place you're stopped is going to be turning out enough output and draining down to, so you can have slightly more tanks in the loop than can fit in one end. But the moment you have fluid to go back, you really want to grab it and go. Because if you've got all the tanks on this end, it means the other end is dry. So I prefer to keep it low. So this is 14 tanks per loop. That has been stable in the past for other loops, and while I'm running more loops this time, loops themselves are not higher in volume, so we should be okay. So I am all set and ready to go to build the nitrogen outpost for the nuclear power plant. And dropping in those resource outposts is pretty trivial. I won't show you building it, but I can lop over here and show you what a typical resource outpost for me looks like. I don't happen to have a nitrogen outpost handy right now. I don't think. Yeah, the batteries don't have a nitrogen loop. But this is one of my sulfur outposts. So down here, I'm mining up sulfur like a demon. I'm getting 720 per minute. I could go to 780, but yeah, it's overkill. Split it 3 ways, and it goes to 3 drone ports. And I've got other ones like this set up, so we'll have a total of 8 drone ports on sulfur. Sulfur nodes look something like this. I deleted the wrong one. That guy's supposed to be there, not there.
So we got
So basically, I'm just dotting the landscape with stuff like this and power. And sometimes it's a little more complicated. So for instance, this guy over here has 3 miners. And instead of having each miner feed one drone port, the problem is that one of these is pure, and one of these is normal, and one of these is impure. So I take all 3 of them, and I send them up to this mess. So each one is split 3 ways. And then for each drone port, I merge 1/3 of each of the inputs. Oh, what a mess. Oh. Anyway, that is a balancer from 3 belts to 3 belts. I know there's easier ways of doing this, but I started working on it, and I laid out the first level, and then I set up a second level that did one merge, and a third level that did another merge, a fourth level that did another merge. I got it all done. I thought I could simplify this, or I could just leave it here. I have since torn down all the foundations that I was using because there were some bugs. There were a couple places where I missed some of these internal lifters. But what happens is, eventually, once you get it done, you end up with these guys. And he is actually paired up with DD1Z Bauxite 3. So each time the drone comes out here, he is going to get a full load of bauxite. And that's going to feed one of the 8 strips. So the only other complicated thing I've done actually is the first thing I did for the nuclear reactor. I wanted to identify where that uranium was, and my little scanning thing, boom, says it's over here. And you come over here. Is it in the water? Oh, this whole thing is so radioactive right now, it's ridiculous. It's below me. There we go. So to go visit my uranium mine, it's a really good thing at this point that I've got all sorts of advanced options turned on. There is a slot in the waterfall.
Hey, I did get an oversuit for turning in
And
that
in
well,
here,
so if you want, we can use it. Maybe
we
it'll
find
feed
the
on
miner.
test a little bit.
And currently his power is turned off. So I turn on his power, he will fill that up. I was radioactive up top because I turned it on briefly to test and then realized I had nobody draining them. So the brief time I had where it was turned on put enough uranium in each one of these drone ports to drive the radioactivity up. It's a little over 6 stacks in each one. So that verified what I wanted to verify, which was that I was actually splitting my uranium 3 ways, and turned it off and like, oh, I've got no way of dealing with that uranium. I can't delete it, can't burn it yet. So I will need to remember once we get the reactor going, that when we turn that on, it's going to drain out that uranium and then stop. That'll make actually a good test of the reactor once I get it built. It'll run that much uranium through the cycle, and if things are bad, it'll drain the uranium out. Once it's done, it'll get all the waste gone.
If there's
So from here, my next step is to refine the power plant plans to the same level that I refined my battery plans, and then start executing. And mostly it'll be dropping these little resource stations around. I haven't decided yet whether I'm going to do the reactor as strips. I don't think it all divides into strips easily. I may have some strips for some of the reactor and some of the stuff in common. So for instance, the waste recycling, maybe just a common area. I may take the I may take it and divide it into 10 strips of 3 reactors and all the support code for them. So a tenth the size, which would give me 18 gigawatts per tenth, which is not a bad idea. Still want to share resources between them. I don't want to have, 10 particle accelerators where one would do. But, that's just an example. Oh, I'm keeping the idea of making plutonium rods and sinking them. That has been wonderful. Oh, I can take up my test stuff here real quick. I'll do that off camera. But you can see these spikes. This is where the main nuclear reactor, the 90 gigawatt, is turning out a plutonium rod that gets synced. So you see these spikes up to 600,000 points per minute. Spike here, spike here. I'm not sure how many that corresponds to, but I got another 21 coupons. Anyway, cut the recording and pull up the syncing stuff here, the batteries, and then start refining the nuclear power plant while placing a whole bunch of resource nodes. And I will be back with another recording when we're all done. So I'll see you next time.